Good day everyone, I am Charles Janmabigaliana and today I am presenting a case study for CPE 412 Embedded Systems. Our focus is on SmartGrid, the future of the electric energy system. This presentation explores the transition from our current aging power infrastructure to a decentralized AI-driven energy internet designed for the 21st century. And next. Before we dive into the technology, let's look at who conducted this work. The lead researcher is Dr. Roger N. Anderson, a senior scholar at Columbia University Center for Computational Learning Systems. This research was a major collaborative effort supported by the U.S. Department of Energy. It was developed alongside industry giants like Consolidated Edison. The project is the result of over a decade of research into learning systems applied specifically to urban infrastructures and energy distribution. And next, the primary goal of this research is to propose a transition from the dumb legacy grid to a decentralized digital controlled energy internet. The first objective is to successfully integrate intermittent renewable energy sources like solar and wind. Secondly, the system must enable distributed generation where energy is produced at the point of consumption rather than a distant power plant. And finally, it aims to create a self-healing grid that can automatically prevent cascading blackouts. The central research questions ask how can AI and adaptive controllers manage a grid with millions of two-way power nodes instead of just a few one-way plants? And next, the methodology for this study is highly technical and data-intensive. Data acquisition: the researchers gathered real-time sensors data from New York City's utility grids. This was combined with data from building management systems and historical consumption datasets to create a complete picture of energy usage. Network nodes: the study involved multiple nodes including urban utility networks, smart meters in commercial buildings, and industrial storage units. Technical tools: two primary systems were utilized. First is the Adaptive Stochastic Control. This is an AI that predicts energy demands. It is stochastic, meaning it accounts for the inherent randomness and uncertainty in how people use electricity. And next is DBOS. This stands for Digital Building Operating System. It provides the interface for real-time monitoring and control within individual buildings. And data processing: a critical step was cleaning the raw data. Sensors often produce noise from oscillations which must be filtered out. The clean data was then processed to machine learning models to identify specific patterns in peak load behavior. And physical implementation: the research also considers the physical hardware such as the controllers and direct boxes that manage the unbalanced and automatic switching of power loads. This ensures the AI's digital decisions are translated into physical grid adjustments instantly. And next, the findings of this research suggest a complete paradigm shift. Packetization: electricity must be treated like data, packetized and routed to ensure efficiency. Storage over plants: small-scale batteries and flywheels or distributed storage were found to be more effective for grid stability than building new massive power plants. Efficiency: through demand response automation, smart monitoring can reduce energy waste in transmission by 20% to 30%. Resilience: the grid can now isolate faults such as a downed wire automatically and without human intervention. Despite these advancements, the researchers identified significant gaps that must be addressed. First is infrastructure costs. The transition requires massive capital investment in high temperature superconductors and fiber optics. And second, cybersecurity. As the grid becomes smarter and connected to the internet, it becomes a target for state-sponsored hacking. And lastly, policy lag. Our current laws are designed for utility monopolies. We need new regulations that allow prosumers, people who both produce and consume energy, to sell power back to the grid easily. To conclude, we are moving from being energy consumers to energy participants. A smart grid is the only way to achieve 100% renewable energy penetration because it solves the intermittency problem. Ultimately, using AI for precision grid management is no longer optional upgrade. It is a necessity for modern urban survival. And that's all. Thank you.